This video will demonstrate how to use a graph and graphing calculator to solve a rational inequality. We want to solve the inequality, the quantity 12 minus 4x divided by the quantity x squared is greater than or equal to 0. On a graphing calculator, we can input the expression, the quantity 12 minus 4x in parentheses, divided by the quantity x squared on our calculator, and graph. We get the picture of this rational function. Remember that there is an asymptote where the function is undefined, that is a vertical asymptote at 0, x equals 0. There is a horizontal asymptote, but we're not going to worry about that right now because what we're trying to figure out is what regions of x make this expression 12 minus 4x divided by x squared make it positive. That is, what regions is a graph above the x-axis. So we also need to figure out what is the 0, right? So you can kind of see that sometimes on a graph and see it pretty clearly, but if it's a fraction or something, you wouldn't be able to see that. So it's also very important before you go too far down this road and rely on the calculator to do everything, that you do some things by hand. So I would want to find, which I've just done in a recent video, but I would want to find where is 12 minus 4x all divided by x squared, where is that equal to 0? And if we cross multiply, we get 12 minus 4x is equal to 0, or where 12 is equal to 4x, or where x is equal to 3. And so that's one of the boundary numbers. The other boundary number comes from where is a function undefined, and that is at 0. And so we can think about looking now at this graph that we have from the graphing calculator and drawing this vertical line through x equals 0, that is where our function is undefined, but also marking off where the 0 is, that is at x equals 3, we're going to draw a vertical line through that, because that is kind of the boundary number between these regions of where the graph is either above or below the x-axis. My inequality suggests I want to find where the graph is above or on the x-axis. And that is, what, to the left of 0, and then between the 0 and the 3. And so my interval would be from negative infinity to 0, which I cannot include because it's a vertical asymptote there, the function's undefined, union 0 to 3, which I can include because I'm permitted to be equal to 0 in my solution set. Another way that I can use a graphing calculator is by entering the entire inequality. We've done this on a few other videos, but I would enter the expression in parentheses 12 minus 4x divided by the expression x squared, and then I'm going to use my test menu that I get to by Second Math and choose greater than or equal to, and then input 0. So I'm entering my entire inequality, 12 minus 4x in parentheses divided by x squared is greater than or equal to 0, and then I'm going to graph. Recall that the calculator assigns 0 to the x values that make it false and 1 to the x values that make it true. And so I can see that it's true to the left of 3, but this can be misleading because it doesn't look like there is a distinction to the left of 3, but we know that 0 cannot be included because that's where the function is undefined. So again, you have to know what you're looking at before you can just go to the calculator and let it give you answers. And so another thing that you could do on the calculator is look at the table. And hopefully the table would tell you, oh, okay, so now I'm seeing all the x values, and in the y column, I'm seeing 1s for the x value that make it true. So at -4, -3, -2, -1, I see a 1. But at 0, what do I see? I get an error message that tells me 0 has to be excluded from this solution set. And then to the right of 0, I get 1s up to 3. And then 4, 5, and 6 all give me values that are 0 So that tells me they cannot be included in the solution set. So my solution set would have to be everything to the left of 0, and then to the right of 0 up to 3. So again, from negative infinity to 0, parentheses, union, parentheses, 0, to 3, which I can include. That's confirmed in the table because I have a 1 at the 3. And so graphically, I'm shading to the left of 0 on a number line, and then a parentheses to the right of 0, shading up to 3 with a bracket.